Hello, everyone. I'm Robert Statzinger. Thank you very much for your time today. I want to talk to you today about security observability for AWS native applications. And I'll just give you a very quick discussion of who I am. I'm a solution architect at Contrast Security. I've been in application security for a few years now. I have a strong prehistoric development background, a strong grounding in APM solution architecture. I'm a cloud enthusiast. I am sort of a more recent imposter to the DevOps and cybersecurity spaces. And I just want to point out that this is not imposter syndrome. I really am a genuine imposter. I'm also an animal shelter volunteer. You can find us on the weekends wrangling cats at our local animal shelter volunteer. And when I'm not doing that, I am singing barbershop music, which of course has been quite a challenge given that they closed all the barbershops because of the pandemic, but we're muddling through. So anyway, I want to talk first of all about how application security has been traditionally done and why it's caused problems for so many businesses. So we have a customer, that a very large insurance company, who was spending millions of dollars on application security, and they had a whole traditional program with static analysis tools and IDE spell checkers and dynamic analysis tools and pen testing and so forth. And really all this got them was the application security really for them became an impedance. All these separate tools and processes limited the speed of their innovation. And, all these challenges meant that after millions of dollars, all they really had was a big backlog of vulnerabilities that really weren't getting fixed and not reducing the risk. So what they really did not have is the ability to observe the inside of their applications as they were running to help really bring to the surface in a consistent and real-time manner how they could improve the security of their applications. And here's why this is the case. We set up these elaborate code pipelines with as many tools as we can that automate things, but what they really generate for us is a list of problems. And for many tools, the majority of these problems are false positives. And that means that people have to clean up the mess. And this creates a security backlog. Unfortunately, the fact that people have to do all of this intervention is what really creates this impedance that ultimately slows down the flow of value to our customers. Imagine instead, if you could do this differently, what you should be able to do is to have your entire portfolio of applications continuously generate their own evidence that you have the right defenses for threats, and those defenses are correct and effective. But even beyond that, what if you could, you need to be able to ask questions of your applications and do experimentation. So if you could see inside your applications as they're being developed and ask questions like, such as, where am I using non-parameterized query statements? What encryption algorithms am I using, and are they the right ones? Which routes are missing access, control checks? How could I get my applications to sort of let me see inside and ask those questions of them? Well, the key to that kind of observability is instrumentation. And instrumentation really is the game changer. Instrumentation is what lets you see inside applications as they're running. It's like New Relic for application security, right? It creates drills and metric. It's like a built-in coach, and it automatically does the work for you of exposing to the outside world all those security problems, so that the humans can actually think more strategically and act more strategically, instead of having to clean up all of the messes from results that haven't really meant anything. Instrumentation enables this deep observability of internal security states in near real time and makes sure they are brought to the surface and given to the right people in the right way. So you can think of it this way. Instrumentation will deputize all the stakeholders in the application development lifecycle as part of the security team. In effect, what it's doing is it's not adding more tools and friction to their existing tools and processes. It's making their existing tools and processes more security aware, more security observant, and calling out that information to the right people. And again, it frees the security specialists from all that work to think more strategically about threat modeling and threat analysis, and enables them to think about what the instrumentation should be performing. Now, how do we make applications observable? Well, we don't have to code it all in. We can instrument it without changing the way people build, test, or deploy software. And this is a very, very powerful technique that the APM companies have been doing for a while, okay? We can add an instrumentation agent to an application. This is not an OS level agent. You know, for Java, it's just a jar file. For Ruby, it's a gem. For .NET, it's, you know, a native module or a DLL. Because these platforms, they provide the APIs and the toolkits that allow you to provide instrumentation and observability inside the application. And it allows you to surgically add what we call sensors to the right methods. And these sensors are the things that measure and observe what's going on inside the application as it runs. And we can record and analyze the telemetry from these sensors to keep an eye on everything in the software. So again, the way this works is you have your original code. The code is loaded by the language platform, and then there's this transformer which selectively injects this library code, this agent code, to place these sensors, and then you just run the code as you would run uninstrumented code, except that it has all of that observability in place at runtime. And the way to think about this is, as I said, you know, you have the security specialists who are out there now free to sort of think strategically about the threats and vulnerabilities that they would like to be able to observe. And they help work to translate those threats into sensors. The instrumentation platform then provides this instant security feedback, this instant visibility. It's like a friend living inside the application, and they have access to everything: the code, the HTTP traffic, the libraries, the configuration, you know, the data flow, the platform, you know, everything. And they can call stuff out, right? So imagine some code is running where there is, you know, a SQL in you know, a SQL query that's not properly parameterized. They're going to call out as things run and say, hey, SQL injection, you know, it's like this built-in coach that's just telling you, you know, stuff you need to know as the code is running. And this is what's really important here is you don't need to be a security expert. Those guys have done their job, right? It's just the normal interaction with your software. Just do your normal testing. That coach in there is going to watch everything that happens and call out everything that happens to you, you know, that happens in the application as it is running. You don't need to exploit anything. All of that knowledge about seeing vulnerabilities has been built into that observability guy inside the application. So why is this rock for AWS and the native cloud? Well, as I said, it's inside applications, which means it's location independent. It doesn't matter where these applications are running. They could be running on developer desktops behind a firewall. They could be running in AWS, in a Docker container, in a Kubernetes cluster. They could be running anywhere, and they're tooling agnostic. They're running inside all of the runtimes. They're deployment agnostic, and they're OS agnostic. So this is really deploy it any way you want, run it anywhere you want, and just interact with it as you're normally doing it. The other thing about this is that it's not sending your code anywhere. Your code stays wherever you want it to run. It's not sending your source code or your binaries anywhere. It's simply capturing that security telemetry, that knowledge of, hey, I saw the lack of parameterized queries at line 25 of count.java, and it's making you aware of that information, outputting it as it sees the code run and making sure it gets to the right people in the right ways. And again, it's also nice because we're not adding to any of this impedance. We're not adding to anything that slows down. We're not adding additional tooling. We're making existing tools and processes more security observant. And finally, there's no scanning. Okay, so nobody is doing any scanning. You can think of this as observing, as monitoring, as your code is normally interacted with, somebody's just watching everything that happens. So, and this is really easy to get started with. This is actually the hard way. I don't really want to linger on this code, but you could just write a simple class for Java, right? This is the entire code to a very simple but powerful Java instrumentation agent for SQL injection. The top part just says, put a sensor into any methods that query a database, okay? And it works on any Java app, right? The sensor itself reports the query and where the query was called for. And you could add this code to your application, right? No other changes, no exports, just a heads up everywhere you're using a non-parameterized query. And you'd use it normally. You're not trying to figure out how to exploit the application. You're not trying to actually do a SQL injection. You're just interacting with this application normally. Now, this is good, but we can make it even easier. And the way we can make this easier is with a toolkit that our CTO has already built. There's an open source toolkit for observability for Java. It's called JOT, the Java Observability Toolkit, right? And it's not that hard to write your own instrumentation. We've created this open source platform that you can use to create sensors fast and easy without any coding, okay? It's just a YAML file format that lets you tell a little jar file what it should be watching for, how to instrument, and what your experiments are. What do you want to observe? What do you want to know in the application? Do you want to know about unparameterized queries? Do you want to know about poor access control? Do you want to know about poor authentication methods and so forth? It allows you to write human readable YAML style sensors and queries to let you ask questions of your Java applications as they run. So let's see how this works. I'm going to actually share the screen and go into a demo environment for you. So here is my AWS Linux environment. You can see I've got an application here. Al, you can see this, correct? I'll assume the answer is yes. So I have a Java web application here called.
Yes, I can. Looks good.
And I've got my JOT toolkit here. I got a little jar file. And the way I run this, I'll show you the run file first, is, I just do one thing. I add this Java agent as a Java tool option. And this Java agent flag says, use my jar file for the Java Observability Toolkit and give it some marching orders for a simple SQL injection observable. And let me show you what that file looks like. So this is a simple JOT, a simple toolkit to expose or make observable simple things that could lead to a SQL injection problem. This is a sensor that says, just show me the unsafe queries. And what this does is it specifies a set of methods in some Java SQL statement packages, okay? And it excludes one. Notice that it's saying if it's java.sql.prepared statement, exclude it from instrumentation, because we know that that's the right way to do it. So we don't need to instrument the class that's the right way to do it. But if there are methods in sort of the vulnerable set of classes there, I need to see all the arguments. So this is sort of a YAML, a human readable set of marching orders that I want to give to my JOT jar file. And when I run the application with this guy in order, you can see that it's reading the toolkit. It says, okay, I got my jot here. And it's going to start up the application, this little ticket book guy here in AWS. You got to love the cloud. So this will connect. And here's the guy. Here's the application. And I can, do a set of clicks here around other things. Really what I can do is anything that's going to generate a database query. I can look in here and say, so what's going on with my ticket? And when I search for that, you can see that I get a little trace here from the jot that says, okay, hey, look, I got an unsafe query here. This is a perfectly legitimate query, but it's not safe, right? It's using an unsafe way of querying the database, right? And you could do this with anything. There are many different kinds of things you could do with jots. And this is just a simple example. Let's do, I'm going to do a couple more here for you. But notice I'm not exploiting the application, right? I'm just saying, show me what's not safe, okay? And it's doing that because it knows that these queries were coded without using that safe approach to parameterized queries. So let's do another example here. I'm going to back out. The next jot is, let's take a look at what we want to do now. Let's talk about access control. Access control is not always an easy thing to test. So this one's a little bit more sophisticated. This is an access control jot that says, look, the first sensor is I want to get all the routes for this application as it's running. In other words, capture all the request URIs that come in through the servlet API. So that's pretty cool. I can see all the sort of runtime pathways. And next, I want to get all the users. And I can do that by capturing a parameter from the get remote user method. And then I want to get the role for that user by capturing the parameter from the isUserEnroll method. So this allows me to see deeply into the behavior of the application as it runs. And then it's going to generate a couple of tables for me. It's exposing to me some interesting visibility. It's going to generate a test coverage matrix and an access control matrix. So let's see what this looks like when I run the application with this jot. So it's found the jot, it's instrumenting the application. It's going to start up again with that jot, that observable in place. And here we are. And so this is nice here. And I'm just going to click through a different set of here. And I'm kind of logged in as a guest user here. And you can see it's generating a test coverage matrix that says, yeah, okay, the guest user, he's not doing anything he shouldn't be doing. He has access to all these pages, right? But when we get down to the bottom, there's some pages that have different access levels. So for role A, I can see that I have that access and it's generating an access control matrix for role A. For role B, I can see that I'm checking access for role B to access endpoint B. For role C to access endpoint C, yeah, I'm making that check. For access D, there is no check. So in other words, role D is not being checked for access control to access this resource. It's proof by negative in this case. I should be seeing a check there, but I'm not, okay? And then for access E, okay, so this is a little crazy. For access E, I see that role A, role D, and role E are all allowed. Now, maybe that's what I want. Maybe that's policy, but maybe not. The point is it exposes to me, it makes observable to me this runtime behavior that I might not know about at all. And this tells the developer of this application exactly where he would need to go and see why this behavior is being exhibited. And again, I'm not exploiting anything. I didn't do anything except normally, basically, functionally exercise the application. So let's do another jot here. This is, I'm going to give you another interesting case here. You can actually have jot throw an exception. And This is a command injection job, right? This is raising an exception to actually block an exploit. So the sensors here are, again, getting the roots here. And this is a sensor called, the second sensor is called block native process, okay? And what this does, it says, if I see the methods I'm interested in are Java Lang process builder, all right? So if, this is a method that allows you to construct a process and launch a process on the operating system where this code is running. And the scope is inside the servlet service here, right? So if we know we're inside the servlet service and we're trying to run process builder, that could lead us to be vulnerable to a command injection, which is a very, very, very serious vulnerability. A bad guy who discovers one of these can run anything on the server, exercise a gadget, steal the password file, and so forth. So this sensor is saying, yeah, we're going to capture the arguments, but we're going to also raise an exception. That was an attempt to create a process builder from within the servlet service. So let's see what happens when we run this guy. So again, it's going to find the JOT. It's going to start up the application. Here from my Amazon Linux environment, and it's going to let me get a hold of this environment. Now, this is going to be interesting because it's going to find, a set of normal things. It's going to print some tracing. It's going to let me do some interesting things here. It's going to let me do expression injection, includes, flows, commands. Now, here's the thing. If I shouldn't be able to do anything on this machine, right? But if I type in something like netstat-a, which would be a command injection on the server, there's that exception, okay? My JOT, in this case, intervened and said, excuse me, there was an attempt to create a process builder from within the servlet service, and I am going to block it. Very simple, no additional code. Installed the instrumentation at runtime. No malicious attempt to exploit the application other than to do something, native in the application. Okay, so JOT is very simple. JOT is very powerful. You can play with this toolkit yourself. I'll go back up here and put the planet level. The GitHub URL here for you. Right now, this is just for Java. I know we would love to see this taken more places. This is completely open source, so I know that Jeff would love it if you fork this, if you take it and see what you can do with it, grow it. Anybody who wants to try to add this for .NET or other platforms to make software easily observable and open would be very much encouraged to do this. So let me make a couple more points in the slides here. In conclusion, and there's the JOT toolkit for you again. You can professionalize this, right? The big brother of this, of course, is IAST and RASP, right? I mean, you can certainly write everything yourself, but IAST and RASP as products, they've done a lot of that work for you. In other words, those JOTs, you have to tell the JOT what methods you're interested in instrumenting, what exceptions there are, and so forth. Well, IAST and RASP have done that work for you. The jar files that you instrument into your applications for IAST and RASP, they already know where to place their sensors. They already know what to expose for you. So we've been in this business quite a while, and we've been able to make that work of making security observable with instrumentation. We've done all of that hard work for you. Okay, in development and test, IAST is using this instrumentation to detect vulnerabilities, tightening up the feedback loops, minimizing the time it takes for you to remediate vulnerabilities, and in production, minimizing your vulnerability to attacks through that same exception methodology. So, modern security is different. Security observability changes the game and accelerates innovation. Okay. When we use security instrumentation to inject sensors directly into the application, we can measure what's actually happening. It becomes automated, no changes to code or process, and none of that manual impedance, that backlog. Okay. And it doesn't stop with development. The instrumentation continues to work right through the pipeline. Continuously monitoring security at every step with feedback on open source libraries too, by the way. And when the app goes into production, you get the visibility into who is attacking, and what they're trying to do. So the instrumentation automatically prevents most vulnerabilities from being exploited as well, even 0 days in libraries, right? So libraries are not things that you have the source code for. And so you're not always going to, even if you had SAST and so forth, those libraries that you pull down for use, they carry great risk. And this kind of instrumentation will protect you from vulnerabilities in those libraries. And all this means pretty much is that your pipeline can run much faster and deliver the flow of business value to your customers. And this is really, the essence of DevSecOps. We're using the power of security instrumentation to create harmony, between security development and operations teams. And we fixed the broken economics of software security, and now security contributes to that maximum flow of value to your customers. And there's measurable results here, okay? And we've seen this with our customers, where observability actually does yield a huge improvement in the mean time to remediate vulnerabilities. And this is a really, really important metric for describing the effectiveness of an application security program. It's a great measure of how far shifted left you are. Now, if your devs are getting accurate feedback immediately, they can quickly check in cleaner code. And so if you look at the numbers in red for SAST, you can see, 29% of vulnerabilities closed in 30 days. And these numbers come from our customers. The median closed in 121 days and 71% in a year. This is not good enough, right? For modern accelerated software development life cycles, this is just too much of a drag. If you look at the line for IAST, what you see is that IAST shifts you left much more effectively. A median closure of 50% in a day and 61% closed in 30 days, 90% closed in a year. And it gets even better once, that's the sort of transient effect. In the steady state, you've worked off the security backlog. The new normal for your organization becomes super effective, right? In 8 days, you've closed 78% of those vulnerabilities, with 95% closed in a year. So that's really effective shifting left of application security and optimizing the speed of remediating those vulnerabilities. I'm going to encourage you to try this for yourself, either with Jot, with our product for free. I'll get to that in a moment. So, application security isn't hopeless. The relationship between development and security is something we work very hard to help resolve. That insurance company I mentioned, well, after a year of using IAST and RASP, they have close to 1,000 applications enabled with security observability. They've worked off most of their application vulnerability backlog, and security is no longer an impedance for them delivering value to their customers. So the key to application security really is getting everybody to work together. Application security can be this notion of it can really be a force multiplier, because it brings all of your development people, all of your testers, all of your software development lifecycle stakeholders sort of as deputized member of the security team, because all their tools and processes become more security aware. Okay, well, if you want to skip the free stuff and go right to the pro tools, we're here for you. As I said, we've done the work of understanding what needs to be instrumented. We pioneered the use of instrumentation in IAST and RASP. You can learn more about us at contrastsecurity.com, and you can get started for free with a single user edition, community edition. That URL on GitHub will get you into a laboratory with a Dockerized version of WebGoat that you'll have up and running in a half hour with a lab guide to lead you through use cases for SQL injection, command injection, cross-site scripting, and so forth, discovering code level vulnerabilities and blocking attacks.